My name is Shin Morimoto. I have been a member of ZCI for a few years, and I belong to the National Institute of Advanced Industrial Science and Technology, which is the largest public research institute in Japan. And today I am going to present about techno-economic assessment of CCU. And recently, Japan is facing a very sensitive problem of how do we allocate the CO2 emissions if the CCU product will transport it across the border. So we have been tackling this kind of estimation. We're trying to harmonize the methodology in domestically, but today I think this is my first opportunity to I would like to show what we have been discussing inside of the Japan, and I want to hear the opinion of allocation method considering this international trade. Now, the first half of my presentation is introducing the tool we have been developed within this 4 or 5 years, and uh, next year I am going to distribute it uh, from the website. So, first half I would like to introduce about my tool, and the second half I would like to introduce about the allocation method if the CCU product will be transported across the border. Now, this is just my background. So, CC, we know that the CCUS and CDR comprises multiple technologies that convert CO2 into fuels, chemicals, and minerals. So, and since this CO2 mitigation is a global issue, and since there are numerous global projects to import or export carbon neutral product, uh, LCA and TEA is very essential for large scale implementation. And the DCI had published the guidelines for LCA and TEA. And also, I am co-leading the LCATA technical track in mission innovation. And in this technical track, we also trying to harmonize the methodologies of LCA and TEA. So within these kind of experiences, the AIST, our research institute, have created a common tool for LCA TEA under several global collaborations. So, and well, I know that like in US, you have the grid model, you have an NETO tool, and also the Planet A, the companies, they provide TEA tool, and like Europe, or US, or Canada, each country or each region have a typical tool for LCA or TEA. But Japan, we never had discovered this kind of tool before. So AIST, as a public research institute, we have been developing this LCATA tool for CCU and CDR from 4 or 5 years ago. And this tool, uh, I am going to distribute from our website. I think at from this end of this year or next year. And I think I have been, introducing several times within this workshop, but over 10,000 case studies is available through the combinations of different CO2 emission source or CO2 capture and separation technologies, the hydrogen production, CO2 conversion, and also, this tool is available to estimate, conduct LCATE of 16 different countries. Of course, we can use for like carburetor minerals or fuels or chemical product. But what is very special in this tool is that the red part is like methane, methanol, the gasoline, and few technology for CO2 capture and separations that we have conducting some process simulation, and all these precise and detail uh, the the operation conditions can be disclosed within this tool. So the database is for few process. The database is uh, well provided from the process simulation, and we have been using this Purdue and Aspen for several processes. So the transparency of detailed technical conditions is available. Also, it eliminates the uncertainty and facilitates the consensus building among project participants. So if you want to know what is the temperature, or what is the humidity, what is the pressures, what is the process flow, how did you estimate the TEA, how do you estimate the equipment cost, all these data is disclosed within this tool. So this is something special. And for the background data, if you want to use like the echo invent or Gabby, you can just put the data inside into this background data, and you can use if you want to estimate what happens in like Germany, what happens in US, the Canada, Australia, the 16 countries estimation is available. So, and in about TEA methodologies, that we have been searching several TEA methodologies. We found out there is an ETL cost model, and also in Aspen, there is Aspen Icarus adopted inside Aspen. This is the methodology for TEA. Also, Planet A, it's the name of the company. They provide some TEA tool. And also, I found that the Global CO2 Initiative also provide a tool for TEA. So what we have been doing is in mission innovation or other global within these other global collaborations, we try to standardize these TA methods within the partners. And the base formula of this TA methodologies is based on this weighted average cost of capital. I think person who is working on TA, this is very familiar formula. And also the total capital cost, the annual cost, all these methodologies were adopted inside of tool, and which has been harmonized within the global collaboration. So and also what is very special in this tool is that we can distinguish what will be the LCATA result will change if the system boundary will change. For example, this is if you choose like system boundary as a cutoff approach, uh, CCU uh, CCU CO2 reduction is estimated with from the difference of CCU fuel and conventional fuel. So you just if well maybe this you all know about this, but for conventional fuel, the CO2 emission from the fuel production and CO2 emission from a fuel utilization. So red and yellow is the total CO2 emission for conventional fuel. While for the CCU fuel, of course there is a CO2 emission from fuel production, but for the CO2 emission from a fuel utilization, this is all already accounted from CO2 source. Since it is cut off from this system boundary, only the red CO2 is counted for CO2 fuel, CO2 emission of the CCU fuels. So the difference of this red and yellow and red is the only yellow amount of CO2, and this we call the CO2 reduction. And also, if you choose like system boundary as like system expansion approach, CO2 source is included in the system boundary. So if you choose this system boundary, the totally totally different. So for conventional fuel, you have the CO2 of the green, which is emitted from CO2 source, is accounted. But in CCU fuel, yellow CO2 emitted from fuel utilization is accounted, but this amount is same as CO2 emission from CO2 source. So we don't have to include the green CO2. So if you just compare this and this, the green CO2 is the amount of CO2 reduction. So again, what is very specific in this tool is you can distinguish the system boundary whether you choose cutoff or system expansion. And also in this tool, the supply chain you can also consider. Like if you like choose Australia or Malaysia or whatever, you can choose which supply chains you are considering. For example, if you want to just simply import fuel from overseas countries, or case five, you want to, well, conduct whole process inside of your country. So you can choose which supply chains you want to consider, and the result will be like provided like this in the tool. You can find out this is the result of CO2 reduction cost. So how much US dollars you needed to reduce tons of CO2. So you can find out, you can do many case studies like UAE, Indonesia, Australia. You can choose the countries, and also you can choose the which case of supply chains you want to consider. So you can estimate the CO2 reduction cost with a different supply chain with the different countries. Well, again, of course, you want to change the country or you want to change the CCU product. You can uh, 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 you can choose any country you want within the 16 countries, or you can choose any CCU product, about 10 CCU products inside of the tool. So you can estimate you can conduct LCA and both TEA within this tool. And again, I'm going to distribute it at end of this year or next year. And this is the first half of my presentation. And the second part is, okay, when CCU product will transport it across the borders, how do we account CO2 from both countries? And what is the TEA for both countries? And this we have been discussing inside of a governmental committee meeting within this 1 or 2 years, but this is very sensitive problems. I wanted to present it today and hear your opinions. So please look at these figures. If the CO2 is captured and converted into a fuel in country A, this CCU fuel will be transported to country B, well, for example, Japan, and CO2 will be emitted if you use this fuel. Now, my question is the CO2, this black CO2 will be accounted as emissions from country A or from country B? Now, right now, we have this kind of SHK system inside of the Japan. And based on these rules, the current rules stipulate that in the case of CCU, the producers of carbon recycled products uh, must be account for CO2 emissions. So from Japan's SHK system, the country A must account this black CO2 emission. And right now, the IPCC guidelines, they're trying to revise it until the 2027, but they do not clearly define how to handle the CO2 if the CCU product will transport it across the border. Now, in this tool, in my tool, we have adopted methodology for calculating CO2 reduction and cost if the CCU fuel will transport it across the border. Now, suppose overseas countries, we select USA. If for country B, we select Japan. So in US, CO2 is captured, converted into fuels, and transported to Japan. If you use the CCU fuel, CO2, the blue CO2 will be emitted. And the question is, should this CO2 be accounted as emission from US or from Japan? Now, uh, in this estimation, well, this is just an example, but I suppose this CO2 be accounted as an emission from US. I conduct LCA and TEA assuming that CCU fuel producer sells the fuel to the consumer, which is Japan, with a 10% profit margin. So if you sell like 10 if it expenditure is $10 per tons of fuels, the U.S. will sell to Japan with $11, 10% of profit margin. It's just a trial, but suppose we uh, do this trial with the 10% profit margin, what will happen? Okay, first CO2 per LCA. Now, CO2 is captured in US. The red CO2 is for producing e-fuel, CCU fuel. And the blue CO2 is the CO2 emitted when they use the CCU fuel in Japan. This red and blue CO2 must be accounted in US. And well, suppose, just example, suppose Japan only can account CO2 for the green, which is the CO2 emission from fuel transport in domestically. Then from US, CO2 capture amount is minus 2.76 tons of CO2 per tons of product. CO2 emission is red part is 0.72. And for use of CC fuel, 2.76. And total, it will be 0.72. And it's larger than 0.48, which is the CO2 emission from liquid natural gas. So from US side, there will be no CO2 reduction for US. But for Japan, we can only account 0.08 tons of CO2 per tons of product, which is a domestic transport. Of course, the use of CCU fuels, CO2 emission will be zero. And for LNG, it's the same account, 2.84. So there, 2.84 is a lot larger than CCC product. So there will be the CO2 reduction is 2.76. For the US, there will be no CO2 reduction, but for Japan, the CO2 reduction amount is 2.76. But if you talk about PEA, the cost of CCU fuel production is 16.8. Well, I estimated with the Japan yen, but setting price is, since 10% of profit margin, it's 18.5. And if you want to compare the cost of LNG, it's 8.4, and setting price is same 10% margin, 9.2. The profit of changing from NNZ to CCU there will be a profit for US for this amount. But for Japan, there is a CO2 reduction, but there will be no profit for Japan since we have to buy a high price of fuels. But there, if you just divide the prices increase on CCU fuel and by the CO2 reduction amount, CO2 reduction will be 3.4 Japanese yen per tons of CO2. What I want to say as a conclusion is for US side, there will be no CO2 emission reduction, but there is a profit or increase by converting from energy to CCU product. And for Japan, there is a CO2 reduction, but there will be no profit. However, we can reduce CO2 with this amount. So in conclusion, what I want to say is that when we talk about how do we conduct LCA and TEA if the CCU will be transported across the border, we have to see both how much CO2 will be reduced in US and Japan. What is the profit for US and Japan? And then we can compare. And after that, we can discuss then what will happen if the US will buy the CO2 reduction, paying the CO2 credit. So right now, if the CO2 emission from using the CCF will be accounted for US must buy a part of CO2 reduction from Japan. But if CO2 emission will be accounted for Japan, then Japan must pay a certain amount of money to buy a CCU credit from US. So this kind of CO2 credit buying and selling, uh, we have to precisely estimate what is the profit, how much CO2 can reduce. So in my tool, this kind of, how to say, the value and estimation is available. So we have been doing this kind of update in my tool. Then we can discuss, okay, which country must buy CO2 credit with which amount? Then what is the profit? Then how much CO2 can you reduce? These kind of discussions to discuss this kind of uh, methodology within different countries. What I want to say is that we have to make the standards, the rules, well, we've had to have common methodologies within different countries. So as a conclusion, what I want to say is that, okay, AISD have developed this tool, and this tool enables case studies of system boundaries, supply chains, countries, but what is more, I would like to harmonize TA methodology with global CO2 initiative. And also, I would like to discuss and create the common methodologies to determine cash flow and CO2 reduction allocations when CCU product is transported across the border with global CO2 initiative. If you are interested in these kind of topics, I can disclose all of my data and all my estimation, the case studies. Of course, these kind of case studies I have done not just with US and Japan, but like Australia, Japan, Canada, US. So, okay, this is it for my presentation, and thank you for attention. But I'm very happy that I, I'm happy with this opportunity to present this kind of topics in this workshop. Okay, thank you.